Welcome to the hints for homework number 2. So we're going to just review it. First part, we have the purpose of this homework, review just a few problems in different configurations, assuming in most cases, not in all of them, but in most cases, that the amplifier is ideal. So over here, we have a problem number 1. Okay, in this problem number 1, we are given basically the voltage conditions, VA, VB, even V out is given. Okay, so we already know that. And the intent of the problem is to find R1. Okay, important thing to remember in op-amps characteristics, right? If the amplifier is ideal, the voltage difference between the two inputs is almost 0 volts, right? Almost. And the current coming into the amplifier, current coming in, right? It's 0, no current at all. No current at all. And well, the output voltage, it's just an ideal voltage source, right? But that's and well, voltage gain infinity, right? But that's already taken into account in the fact that the two input terminals are almost equal. So this probably what you need to do is to use your circuit analysis techniques and find an equation for R1. In other words, work your solution in terms of R1, and at the end just solve for R1, and that pretty much is the solution for this particular problem. So for the problem number 2, it's very similar. It's a problem with a very similar configuration. The only difference is that the output saturates to the positive voltage supply. So what we have, we are given values for VA, resistor 1, resistor 2, and the fact that the output saturates to the positive supply. Note V out is equal to 5 volts. So we just repeat the same technique to find the solution for this problem. Okay, no big deal. Next problem, it's a gain multiplier type of circuit in which the output voltage is a function of the feedback resistors inverting, right? Because it's in a inverting configuration, so the gain is negative. And the reason we have this T network on the feedback is such that the resistors, the ratio of resistors are not too large when the gain needs to be high. Okay, so if you name a node here Vx, you can say your nodal equation, right? Use nodal equations and finally your solution for I4 is going to be equal to Vx minus V out, right? Divided by the resistor R4. Okay, just very simple problem. Okay. Next question. It's a circuit that actually has a very interesting use, particularly when one of the resistors is a potentiometer. So if we actually set the resistor 2 to be a potentiometer here, what we want to know is what to observe is what happens to the output. So first question is find the voltage gain for the resistor given. And then for cases in which R1 is related to R2 by this equation, right? 2R1 is equal to R2. And third case is when R2 is 3 times R1. So we have 1, 2, and 3. And what we want to understand is what happens when we change that particular resistor. Okay, good. So now next problem. It's a current amplifier. This time you have a current coming in, I in. So the current I in comes from this way, and the current I out is the resistor that goes into the amplifier, right? I out has to continue here, and we are asked to find the ratio of the two currents. So we use the same nodal analysis techniques for ideal amplifiers. The different voltage between the two inputs is almost 0, and the amplifier doesn't take any current. That's just our considerations for working the problem. The next one is an interesting problem because it's used for cases in which we have a single supply. This case is VDD and ground, so we don't have the negative supply, it's only positive. So we need to generate some voltage in between to refer the signal to. In this particular case, this node is actually a midpoint. So it's connected on VDD on one side, ground on the other, and you see these two resistors are equal. And well, normally for DC conditions, this current is 0, right? 0 current this way, and the capacitor also blocks the current only for DC. So we can say that at DC, this is VDD divided by 2, right? But that's not the point of the problem. The point of the problem is to actually work your simulation, which is the computer simulation, to find the poles due to each capacitor. So we have 1 pole, 2 poles, 3 poles, 4 poles. So what we want to be able to do using your simulation is to find the corresponding pole to each of the capacitors. Now you can work this problem analytically if you want. It's actually not that hard, with the assumption that this capacitor C4, right, if you actually look at the numbers, is sets a pole at a very low frequency. And well, I'm already helping you with a little bit with the solution. Finally, the last part is to find the power supply reaction ratio, right? Power supply reaction ratio, just as a reminder, is equal to the ratio of the voltage gain, AV, with respect to the source, right, VDD, with respect to the voltage gain from the signal. In this case, signal, right? So we have the signal gain is V out, of course, divided by V in, and this gain from the voltage supply, well, is V out over VDD. How much gain do you get there? And express that in decibels. Okay. So basically, we want to find that actually not at any frequency, at 1 kilohertz, and you can just answer that in your question. And that's it. Very short question, very short homework. I hope you get it right. Leave a comment if you have any questions. Thank you.